Are you guys ready for it? Are you ready? Here it comes. It's coming. It's right here. I'm so excited. I have a logo and it's perfect. It's so perfect for me. I'm so excited. Hello and welcome to Math Monday. I'm talking more about exponents today because I could just talk about exponents forever. There's so many things to do about exponents, and every time I think of one thing, I think of another and another and another. So exponents are so important, especially if you're just starting to go into high school math, because you need to know these exponent rules so well, like the back of your hand so well, because they go into so many other things. First, I'm going to go over products to a power there. So we have a power or an exponent, and we're raising it to a product. Remember, a product is two things that are being multiplied together. So when would this be a situation? Well, say we have 2x. 2x means 2 times x, so we're technically multiplying them together. So they're a product, but we can't actually multiply them together because they're a number and a letter. We just can't. So say I take that to a power, say the power of 3. What does that mean? That means 2x times 2x times 2x, right? That's what an exponent of 3 means. That we can just rearrange a little bit because it's 2 times x times 2 times x times 2 times x. So we can put all the 2's together because we can multiply those. So that's 2 times 2 times 2. And then multiply all the x's together. That's x times x times x. Oh, doesn't that just look like 2 cubed times x cubed? It kind of does. And we can furthermore figure out what 2 cubed is. 2 cubed, 2 times 2 times 2 is 8, and then we just leave the x cubed as x cubed because x isn't a number, so we can't figure it out further. So that's our rule. When you have a product, so we'll call them two random letters, a and b. So when we have a times b and I'm raising it to an exponent of m, I just take a, raise it to the power of m, and b and raise it to the power of m. And that's how we get a to the power of m times b to the power of m. There you go. You can do the same thing with a quotient. Remember, quotient is what happens when you're dividing. Another name for a quotient is a fraction. I've seen this so many times. People don't know how to raise a fraction to a power. It's actually something you're taught when you're a bit younger, but a lot of people just forget. So here's your reminder. So say I had something like 3 over 4 to the power of 2. So I'm not even going to bring in algebra into this, just 3/4 to the power of 2. What does that mean? That's 3/4 times 3/4, right? I multiply it twice. To multiply a fraction, you just multiply the top numbers together and multiply the bottom numbers together. Remember, multiplying fractions is the easy thing to do. That's 3 times 3 over 4 times 4. Oh, 3 times 3, 3 squared is just 9. 4 times 4, 4 squared is 16. There we go, we get 9 over 16. So you see, when we squared that quotient or that fraction, we just squared the top and squared the bottom. And that's really all you do. It's actually that easy, but so many people forget that. So let's generalize this a little bit. Our rule for raising a quotient to a power is a over b to the power of m is equal to a to the power of m over b to the power of m. Remember, where a, b, and m are just numbers. They're any numbers. They're probably going to be integers, and they're b is not going to be 0 because you can't divide by 0. But that's all it is, okay? One more rule for you today, and I'm just going to give you the rule straight out. I'm not really going to explain it because this is just how numbers work. So the rule for negative exponents is x to the power of -1, x being any number, is equal to 1 over x. We don't like negative exponents. So when we have a negative exponent, we need to move it to the other part of the fraction. If there's nothing on the top of the fraction, you just put a 1, okay? So this can actually work the other way. If the negative's on the bottom of the fraction, you can bring it up to the top as well, and then you have a positive exponent, okay? So what that means, let's do an example with algebra. Say I had 3x all to the power of 1. I know it's all to the power of 1 because there's brackets around it. Those brackets mean everything in these brackets is being raised to the power of -1. So that's actually equal to 1 over 3x, okay? But something that people have a hard time with so much of the time is when I have something like 3x to the power of -1. They still think that 3 is being raised to the power of -1, but now there's no brackets. It's not. The 3 and the x are separate. They are completely separate entities, And then -1 now only applies to the x. So if I have 3 times x to the power of -1, that 3 stays on the top of the fraction because it's happy. It has its positive exponent of 1. So we have 3 over, then we have x, or x to the power of positive 1 in this case. Okay? So remember that. It's a common mistake I see all the time for people. So don't worry if you make it every once in a while, as long as you learn from that mistake. I'm going to go over an example. Again, I'm happy to go over more examples. I'll probably do a little bonus video of just examples to work through. So if you have examples that you've worked through and they've been really tough, please send them in, and I'd be happy to go over those with you. So the example I have here, I have 3x over x squared y all to the power of 2. So I can just divide those x's right now, but I'm not even going to worry about that. Let's look at this exponent. So we have to remember that the exponent of 2 applies to everything inside the brackets. So that means I'm taking the 3x on the top and squaring it, and I'm taking the x squared y on the bottom and squaring it as well. And a little extra step here, you never have to write this step down, but now remember when we have a product like 3x, and we're squaring it, we need to square the 3 and the x. So it's 3 squared x squared on the top. And on the bottom, we have x squared y to the power of 2. So that's x squared squared and y squared. So just remember that. That's something that you can kind of do internally. You don't necessarily need to write that step down if you don't have to. What we end up having is 3 squared is 9. X squared is x squared. That's on the top of the fraction. And that's going to be over x to the power of 4, because remember last week we learned x squared to the power of 2 would be 2 times 2, so that's x to the power of 4. And then y squared. Are we done? Is it done? Is it good? Are we good? We're not good. There's actually one more thing you can do to simplify. So people always ask me, what does simplify mean? If there's anything left to divide, you have to divide it. Okay? Here we have x on the top, x on the bottom. You can never have that. That means you can divide. So that x squared over x to the power of 4, we can divide those two. So remember, to divide powers with different exponents, you just subtract those exponents. So 2 minus 4 ends up being -2. That's weird. So we have 9x to the power of -2 over y squared. Remember, we do not want negative exponents ever. So what do we do when we have this -2 exponent? So that's when we're going to bring this thing with the negative exponent and move it to the bottom of the fraction, and it's going to have a positive exponent. So last time we were working with power of -1. Here we're working with -2. So the -2 is going to become a +2 on the bottom of the fraction. So we move that. We don't move the 9 because the 9 is happy where it is. It has a positive exponent of 1 right now. It likes being on the top of the fraction. So we leave the 9 on the top of the fraction. On the bottom of the fraction, we'll have the x squared and the y squared. Also, it doesn't matter which order you write those in. The x squared, y squared, or it could be y squared, x squared. It's up to you. There we go, we're done. There's nothing left to divide or anything like that. There's no more powers we can actually evaluate. Now we are officially done. So again, if you have any questions or any examples that you want me to go over, please feel free to comment below, or you can send me an email with a picture of the example that you want me to go over. I'm happy to do that. Again, I'll probably do a bonus video of just a bunch of exponents examples and working with these exponent laws. There's still a few more exponent laws to go, so I will go over those another day, but I think that's enough for now. Anyways, I hope you guys have an awesome week, and I'll see you next week. Bye.